Hi everyone! Today we're talking about the area of composite shapes. This is our introduction to this topic. Alright, as you can see, I've got this funky looking shape on the page here. I mean, it looks like a house a little bit. I can see the roof of a house and stuff, but this is not like an actual shape that has as a name, like a square, rectangle, circle, and those nice basic shapes. This is just a randomly drawn irregular shape, we call it. And the thing about it is a composite shape, meaning it is made up of, there are smaller shapes inside of this that we can pull out. So today we're going to talk about how do you find the area of a shape that looks like this, funky like this, right? And remember, area is the space inside of a shape. So as you can tell how this one has been shaded inside, that's the area. So again, you're going to have some formulas and rules and steps that go along with that you're going to see. You should be writing everything down in your notes and keep track of everything. All right, let's get started. This warm-up requires you to find the missing sides and also the area of the whole shape. So even though we've not technically learned anything yet, I feel like there's parts of this that you already know, and we're going to apply that. You see the two missing sides here. You can figure out what those are by using a little bit of visualization, a little bit of logic here. You need to use your imagination actually. Okay, let's work on this that missing side first. If we pretend, or actually let's notice that right here it is 6 centimeters long, and then over here it is 3 centimeters long. So that means this missing side, right? That would mean, like, if it's right here, the same thing would be there. So this whole side needs to kind of match this 6. And so, well, if it's 3 from here to here, what would the remaining, or that gap, be? So you would just do 6 minus 3, which gets you that this missing side is 3. You see that? 6 minus 3, because we're trying to find that gap right there. So we've got one of the missing sides, and that takes, like I said, you got to imagine those lines. All right, where's the other one? This one we're working on. We're working on figuring out that missing side. Again, let's use what has been given to us to find the rest. Right here we've got 9 centimeters all the way across. And so if that missing part, if that line was also down here, just as something for us to imagine. So if we have 9 all the way across and then 5 from here to here, what would that little gap be, the remainder, so that the whole line gets us 9? Well, that would be 9 minus 5, which is 4. Now, I don't know if my explanations were confusing or actually cleared up any doubts, but what I'm trying to say is you had to visualize that. And on a piece of paper, if you could really draw on top of the picture, that really helps. Okay, so we've got the missing sides. Now we find the area of the whole shape. Because there are squares in between, right, that this picture's been drawn on like graph paper, it looks like, you can just count all the squares. This should be like something you did in 4th grade, elementary school for sure, where you had shapes and you just counted the squares inside to find the area. So you would just count everything. To make it easier, there's some shortcuts. You could do 1, 2, 3, 4, 5, 6, and then across. 1, 2, 3, 4, 5. So 6 times 5 is 30. So you've got 30 right here in this larger rectangle. And then for the smaller rectangle, I mean, you could sit there and count every single square, I guess, or you could do 4 times 3 for here, that's 12. So together, 30 squares plus 12 squares, that is a total of 42 squares. And so the area of this shape is 42. We did that by counting the squares. Now, That's just the basic way. In a minute, you're going to find out how to do it the proper mathematical way, which is not by counting squares, but by using formulas. So let's get started on that. Your objective today will be to find the missing lengths on shapes, like we just did in the warm-up, and also to find the area of composite shapes. So by the end, if you can do those two things, that means you understand. You will also need, just as some helpful tools, if you have 2 or 3 different colors like highlighters or a different colored pen or colored pencils, grab those because we're going to do some shading and things like that. Alright, at the top of your notes, it's going to say composite figures or shapes. Either one, I could use either word interchangeably. Composite figures are figures that are made up of more than one shape. More than one shape. So instead of just being a circle or just being a rectangle, it's more than one thing put together. We have 3 steps to finding the area of composite shapes, figures. Always use these three steps. Step number 1 is to separate into individual shapes. Separate into individual shapes. Hope you can read my handwriting. After that, we're going to find the area. Find the area of the separate shapes. And then last step is going to be to add to find the total area, and this is our final answer. So here are the 3 steps. Let me read them out loud in case my handwriting is terrible, which it is. Separate into individual shapes, find the area of the separate shapes, and then add it all up to find the total. Let's put this all together in application in some examples, and I'm guaranteeing you it's going to make sense. Today we're just going to do a few simple basic composite shapes, right? Nothing too difficult for today since it's just our introductory lesson. Here's example number 1. Okay, this shape doesn't have a name, it's just this random L-shaped thing. So it doesn't have a special formula that goes just for it. What we have to do is use our previous knowledge. How many different ways can you cut up this shape? You can cut it up like that, right? And make yourself a square on the top and a rectangle at the bottom. You see that? Or I bet some of you, it depends, our brains all work differently and we kind of see things differently. Some people might see that you turn it into 2 rectangles. This rectangle right here and then the rectangle up here. Both ways are correct, guys. I mean, it's just how we visualize. It's different, but both are correct. You would get the same answer. And can you find a third way of separating this? Maybe you're a little more advanced and you could turn these into what are called trapezoids. 2 trapezoids. Now, I will admit this is unnecessarily complicating things. If you were to, this is not the most obvious way. In math, sometimes we want the simplest method. Most of the time, we want the simplest, straightforward method. I just wanted to show you that there's many different ways of cutting it up, of separating it. You pick what you prefer whenever you're doing a quiz or a test. For the sake of this example though, because I want you to copy what I'm doing, go ahead and let's do it. Let's make a square and a rectangle. A rectangle here at the bottom and the square at the top. So here's where the colors come in handy. This is what I was talking about, if you can shade, because it makes it super obvious and they look, separated and individual. There we go. So now we've turned that funky L-shaped thing into two manageable shapes. We have a square and a rectangle. So we've done step one. We've separated into individual shapes. Now we find the individual areas. How do we find the area of a square? Area of a square is base times height, which happens to be 3 times 3, which is 9. Okay, leave that alone. We'll come back to that later. Let's let's tackle the rectangle. How do you find the area of a rectangle? You just pull out the rectangle formula, which is base times height. So we do use formulas, but we use the old formulas, right? And so we've got 10 as a base. Here's where we run into a little problem. This would be the height on the side, but that's not been given to us. We don't know that height. That's a missing side that we need. Can we use given information to find that missing side? Can we use the fact that up and down this whole thing is 5, and then from here to here this much, that's 3, so then the leftover would be the gap, right? It would be 5 minus 3 to give you that missing length, which happens to be 2. This length right here is 2. And so for our base times height, we have 10 times 2, which is 20. So we have the individual areas. The square is 9 and the rectangle is 20. So together, what would be the whole area of that L-shaped figure? It would be 20 plus 9, which is 29, and now we put our units, 29 centimeters squared. Okay, hope you copied down everything step by step and the steps made sense. Yes, of course, from tomorrow and on future days, the shapes will get a little trickier, the numbers will get harder, there'll be decimals, possibly fractions. So yes, it does get trickier as far as the numbers go. But the concept is what I want you to get of you take a big funky looking shape, excuse me, and you cut it up into smaller shapes that you are familiar with. And you put it all together at the end and get your total area. All right, let's do a couple more examples. Rewatch any of that if you need to, if it doesn't make sense. Okay, we've got some rocket-shaped thing or house-looking thing. You can instantly see what two shapes are in here, right? Because they've actually drawn a line. But I'm going to color code just in case. We have a triangle on the top and a rectangle on the bottom. These are our two shapes, triangle, rectangle. We need to find their areas separately and then put them back together. How do you find the area of a triangle? It is area equals base times height divided by 2. So that would be, what is the base of the triangle? They did not put the number right there, but it would be the same 5 would kind of continue up here, right? So it would be 5 times, what's the height of this triangle? The height would normally be here and usually with a dotted line. They haven't labeled it. But can we figure that out? By using the fact that it is 18 all the way up and down, and then it is just 10 from here to here. So what would that leftover part or that gap that would represent the height be? Whatever 18 minus 10 is, which is 8. Okay, that step is very important, guys. It's something you have to visualize and be able to understand. If you don't understand where I'm getting this number from, the 8, I guess this kind of like I'm going to throw a wrench in the wheel, as they say. You have to use other pieces of information that we do know and really the visualize that gap basically that's missing. 18 all the way up and down minus the 10 gets you the 8. Okay, so finishing up that formula, 5 times 8 divided by 2, 5 times 8 is 40, divided by 2 is 20. We have solved for the area of the triangle. That stays off to the side for now. Okay, and then now we solve the rectangle. Area equals base times height. Okay, the rectangle is 5, base of 5, height of 10. 5 times 10 is 50. Put it all together. Triangle plus rectangle, that would be 50 plus 20. Area of 70. And there's no units on this, so final answer is 70. Okay, rewatch if you need to. Final one. A little bit trickier because it has a couple of trickier shapes. We have a rectangle, we have a triangle and a half circle. Alright, so watch carefully. This is how we do it. Let's color code. We'll make our our triangle one color, just to make it different. And our semicircle a different color. We'll pull these apart. Triangle. And semicircle. We'll talk a little bit about this semicircle because we know the formula for circle is not necessarily a semicircle, but you'll see that it's how, a semicircle is, how is it related to a circle? We'll talk about that. So let's do the area of a triangle first. Area is base times height divided by 2. Okay, so what's the base and the height? Here's the base of the triangle, 12 times height. Height is usually given as a dotted line, so that's 8 divided by 2. 12 times 8 divided by 2. That's 96 divided by 2. 96 divided by 2 is, what is it, 48? Yep. Okay, so that's the triangle. It's off to the side. Now the semicircle. Let's pretend, and then here's how you solve a semicircle. We have to pretend that it is an actual full circle, just pretending to help us out. We'll do the semi part of it later at the end. But we pretend it's a full circle and we use the circle formula, which is area equals pi r squared. Pi is 3.14. R is actually not the 8. R would only be half of the 8, so that's 4 squared. 4 squared is 16, and then we have 3.14. I believe that comes out to 50.24. Okay, now pause right there. We're still on the semicircle, but we were pretending it was a full circle. So what we did is we found the area of, if that circle was a full regular circle, this is what we found out, 50.24. But it's not a full circle, is it? It's just half of a circle. So what would we do to this area that we got? We would take half of it, divide it by 2 to get the semicircle, right? And so that would be 25.12. There you go. So now we have the semicircle and the triangle. Can we put them together to get our final answer of this weird composite shape? Of course, we just add them both up. 25.12 plus 48, you want your decimals, oops, that is so messy, plus 48. Line up your decimals and add 1373. 73.12 meters squared. Okay, so there it is. Here's the basics about composite shapes. Could you Do you think you meet this objective? Can you find missing lengths? Of course, we'll do more practice on this. Can you find the area of composite shapes? At least, for today, the simple ones. Can you separate a shape into smaller shapes? Can you find the individual areas first and then add them back together? Okay, so this is the main topic for today. If you can check off on those objectives, that means you understand and you should be able to do your homework. Email me if you have any questions or doubts. All right, thank you and goodbye.